So once again, the lights are out and we've run out of power in the shed. So all of these DC converters and switches and stuff are all off because, again, the batteries have tripped. The protection has kicked in on the BMS. The reason this keeps happening, of course, is because I've got parasitic loads. I've got Wi-Fi routers, security cameras, aircraft trackers on all the time. So there's, of course, the big aircraft tracker there on the wall. And when it's been cloudy for a few days, the parasitic load of that drains these batteries down. So I need to come up with a solution. So first I've got to reset these batteries. So I need to flick the switches up here to turn everything off, get my resistor, and then connect it across. So one end of the resistor is connected to the negative switch side of the BMS, and the other side goes to the negative side of the battery. It's connected, and hopefully, so that will be charging up the caps in the inverter, and the inverter is off, and eventually that will build up to enough charge that I can turn on the power again. In fact, you can see lights are coming on, and we are kind of charging. That's a weird pattern. Weird how the PV light is flashing. Overcharge, over voltage. Interesting. Saying the batteries are full and the panels are over voltage, but the panels aren't over voltage because they're 36 volt. Oh well, might be low voltage on the battery. That's confusing it a little bit. It's not drawing any current. I'll leave it a few seconds. So the batteries are reading 21.9 volts. So they are low. I mean, they should be 24, probably cut off about 22, which makes sense. I don't know why it's flashing saying over voltage, because it clearly isn't, unless it thinks it's a 12 volt system, because voltage is so low. Bit weird, but yeah. Anyway, that is still not charging. That's worrying. Why is it doing that? As you can see, I am confused. Right, I've had a think, and I think I know why it's doing this. So when I put the resistor across the BMS, I left the inverter connected, and there's big input caps in the inverter. So because it's across the resistor, the voltage would have risen slowly. So it would have gone past the 12 volt threshold. So this would have started up at 12 volt setting. And of course it's gone all the way up to that 22 volts. And so now it's 22 volt for a 12 volt system. So I think if I just disconnect the battery cable, plug it back in again, it should start up in 24 volt mode and then start charging. I done what I said I was going to do, and I did it. And I removed the cable and put it back in again. It's now started up in 24 volt mode, and of course it's now saying battery is low, which of course it is. And it started charging, so it's pulling 52 watts, 53 watts. So that's good. So it's charging. I shall leave these switches off so there's no load on anything. Make sure that's definitely off. So there's no parasitic loads, so that will charge slowly over the next few days. Still going to be rubbish weather next couple of days, but if we get a few 100 watt hours in, we should at least be able to maintain the charge and turn things back on. But I have a plan how to solve this problem. Welcome to my plan. So this is a breadboard with a Raspberry Pi Pico. It's their new board they've released, and I'm sure there's loads of videos already about it. I was lucky and managed to get 2 on the day of release. So I've been playing with this for a few months already. I've got a DC converter here. So this takes the battery voltage in with a resistor divider down to an ADC on the Pico. And then I've got the same chip that I used to drive the motors on the RC car project, and instead I'm using that to drive a latch-in relay. So this relay is quite cool. So you don't need to have a constant voltage across the coil or power draw to keep it latched. All you reverse the polarity. So you put a pulse of voltage across the coil and it latches one way. Pulse in the opposite polarity and it goes the other way. So with this chip I can just effectively go forwards, then brake, and it uses no current, and then backwards go brake. If you saw the other RC car video, you'd kind of understand what I'm going on about, or not, because I might just be confusing myself. And then I've got some NeoPixels. I'm not using the whole strip, I'm just using the first one. and that will basically be an indicator for the voltage level. So I've designed a PCB, which I shall hopefully be getting in the next few days, and this could become AMY2. And if you have no idea what I just said, AMY1 is this board. This is a battery protector for lead acid batteries that I've built and sold. I'm basically redesigning this, but for lithium iron phosphate batteries. So that is the first prototype version of it, and then hopefully we'll be able to design and build them and get them out in the world. So yeah, this is very much prototyping stage, and I shall keep you updated how it's going. But for now, that's just a quick update of how I'm going to solve the problem of the batteries in the shed. So for now, I shall see you later. Bye.